welcome to True Projects. In this video, we are going to explain about the project which is Cost of Living Predictor in foreign countries. In an increasingly globalized world, individuals often face the challenge of understanding and managing the varying cost of living when they are relocating or traveling to foreign countries. This project addresses this issue by providing accurate cost estimates based on user input features, helping users to avoid financial surprises and effectively plan their budgets. The primary purpose is to empower individuals, travelers, with the information that they need to make informed decisions about living or visiting different countries. By offering cost predictions and insights into various expense categories, it enables users to plan their financial resources effectively and choose destinations that align with their budget and preferences. The project solves the problem of financial uncertainty and the risk of overspending when they are moving or traveling abroad. By breaking down the cost of living into categories such as housing, transportation, food and entertainment expenses, it provides users with a clear understanding of their potential financial obligations. This transparency enables users to confidently budget for international experiences and make well-informed decisions, ultimately enhancing their ability to navigate the complexities of global mobility. The main goal is to develop a cost of living prediction system for foreign countries. This system will provide users with accurate estimations of living expenses, enabling them to make informed decisions about traveling or relocating abroad. The project aims to employ machine learning algorithms including linear regression, decision tree regression, random forest regression, and voting regression to achieve its goal. These algorithms analyze historical cost data and use input to predict the cost of living in different countries. The ultimate goal is to elevate the financial uncertainty and challenges individuals face when they are moving or traveling internationally. By offering reliable cost estimates, the project aims to empower users to plan their finances effectively, make informed decisions about foreign destinations, and enhance their overall international experiences. For implementing the project, we need two requirements, and they are hardware and software. Coming to hardware, operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above are included. Coming to software, we need Anaconda 3 and Visual Studio Community version. For implementing the project, we have designed few modules in the project. The first one is importing the packages. In this module, various Python libraries and packages are imported to support different aspects of the project. NumPy is imported to handle numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for visualization, and scikit-learn for machine learning. Exploring the dataset. In this step, the dataset containing cost of living data for 2022 is loaded and explored to understand its structure and contents. Data processing. This module involves data cleaning and preparation. Dropping unwanted columns using Pandas data frame to remove unnecessary information. Dropping null rows using the .drop function to handle missing or incomplete data. Visualization using Seaborn and Matplotlib. This step involves creating data visualizations using Seaborn and Matplotlib libraries. It helps in understanding the data's distribution and patterns. Label encoding and feature selection. Label encoding is applied to categorical features to convert them into numerical values. Feature selection techniques are choose the most relevant important features for the predictive models. Building the models. This module involves constructing different regression models for cost prediction purpose, and they are: the first one is linear regression. Linear regression is a supervised machine learning algorithm used for modeling the relationship between a dependent variable and one or more independent variable. It is used to establish a baseline model for cost prediction. It's straightforward and interpretable, making it a good starting point for understanding how individual features influence the cost of living. Decision tree regression. It is a regression algorithm that uses a decision tree to model the relationship between the input features and the target variable. It breaks down the data into segments and predicts the target variable for each segment. Decision tree regression is employed to capture nonlinear relationship between features and the cost of living. It can handle complex interactions, and it is useful for improving prediction accuracy. Random forest regression. It is an ensemble learning method that combines multiple decision trees to make predictions. It reduces overfitting and improves accuracy by averaging predictions for multiple trees. It is used for further enhancing prediction accuracy. It reduces the risk of model overfitting and provides robust cost estimations. Voting regression. Voting regression or ensemble voting combines the predictions of multiple machine learning models to make a final prediction. It can use various methods such as majority voting or weighted voting. Voting regression is used to leverage the strength of multiple models to achieve a more accurate and stable cost prediction. It combines the output of different algorithms to mitigate individual model bias. Logistic regression. It is a classification algorithm used for binary or multi-class classification tasks, but it is not typically used for cost prediction. It models the probability of a sample belonging to a particular class. Logistic regression is included for the extension of this project, possibly for additional classification tasks related to cost of living. Coming to training the model algorithm module, in this step, the selected models are trained on the pre-processed dataset to learn the relationships between input features and the cost of living. The next module is Flask framework with SQLite for sign up and sign in. In this module, Flask and a web application framework is used to create a web interface for user sign up and sign in. SQLite is employed as a database system to store user information securely. User give input as a feature values. In this step, user provide input values representing their preferences and requirements for cost estimation. The given input is pre-processed for prediction. The user input is pre-processed to match the format expected by the trained machine learning models. The trained model is used for prediction. The pre-processed input is passed through the trained machine learning model to predict the cost of living based on the user preferences. Final outcome is displayed through front-end. Predicted cost of living is presented through the user interface project's front-end, allowing them to make informed decisions about their financial planning for international travel or relocation. Comparison graph. Here on the x-axis we have the R2 scores of the algorithms, and on the y-axis we have the algorithm names. Among all the algorithms, voting classifier is performing well, so we will use voting classifier for the purpose of prediction in the web interface. For execution, we need to open the code folder which contains the source code files. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file which contains the algorithm information, and this will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign up file. This file is the database file used to store the user information. Now we need to copy the code folder path from the address bar of the file explorer. So we'll copy it and open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This command is used to change the current folder to the code folder's path. So it has changed to code folder's path. Here we need to type python space app.py and then click on enter. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number. This is the localhost and this is the port number, unless configured differently. Now we need to copy this local link and paste it in any browser. I prefer Google Chrome, so I will paste it in that. So here I need to paste the link and then click on enter. So this has redirected to the web page which is displayed in the browser, and this front end is built using the Flask framework. Now we need to click on sign up. So we need to fill all the registration details if we are registering newly. I have already registered, so I'll directly click on sign in. Here I need to provide my credentials, which are username and the password, and click on login. So this has redirected to the web page, home page of the project. Now we need to fill all these parameters step by step and then click on predict. So we will fill the details. So we will select the country as Belgium and the cost of living index as 72.61 and the rent index as 25.79 and the groceries as 63.32 and the restaurant price index as 78.63 and the local purchasing power as 79.72. Now we will click on predict. So it has predicted that the cost of living is expensive and the rent is 4,190k per year. Now we will give the other expenses, other countries' expenses, and then see what will it predict. So here we will give the Afghanistan as the country and the living index as 20.37, rent index as 2.72, and the grocery index as 14.92 and the restaurant price index as 12.41 and the local purchasing power index as 23.04. Now we will click on predict. So for this particular country, it is predicted that the cost of living is inexpensive and the rent is 1000.79k per year. Now we will fill the other country details index. We will choose the country as Indonesia and the cost of living as 35.85, rent as 9.82, grocery index as 38.29 and the restaurant price index as 17.74 and the local purchasing index as 21.04. Now we will click on predict. So it has predicted for this country that the cost of living is moderate expensive and the rent is 1956.9k per year. Now we will give the other country details and see what will it predict. Here we will give the country as Bermuda and the cost of living as 146.04, rent as 98.58, grocery index as 148.66 and the restaurant price index as 159.17 and the local purchasing power as 81.07 and click on predict. So it is predicted for this country that the cost of living is very expensive and rent is 10,239.5k per year. In this way, we can enter the index parameters and then click on predict for the particular country, and then we will get the predictions for that particular country, that whether it is expensive, moderate or inexpensive. Now we will sign off. The project has successfully created a sophisticated cost of living prediction system. Underpinned by advanced machine learning algorithms, its primary aim was to empower individuals, travelers, to take charge of their financial planning when considering international ventures. By providing them with the precise cost estimates based on their preferences and needs, it equips them with the essential information required for budgeting and decision making. In an era of global mobility and diverse international opportunities, making well-informed choices is paramount. This project, through its data-driven precision and transparency, contributes significantly to informed decision making. Users can gain insights into various cost components, including housing, transportation, food, and entertainment, allowing them to tailor their plans to match their financial capabilities and preferences. Ultimately, the project strives to optimize international experiences. It achieves this by reducing the uncertainty and financial risk associated with the living or visiting foreign countries. Users can embark on their journeys with confidence, knowing that they have access to a reliable tool that facilitates effective financial planning. This not only ensures a smoother transition into new environments, but also enhances the overall quality of international experiences, enabling individuals to fully embrace and enjoy the opportunities that the world has to offer.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.